All right, moving on. We're going to do 2 videos on 3.4. This first one, we're just going to look at exponential equations. You can basically see from these 8 problems that exponential equations means we're going to have x right here as an exponent, and we're going to solve for x. And we're starting out for 1 and 2. This is actually going to be a review. You probably saw this in Algebra 2. These are the easier cases. You probably even know what number 1 is just by using mental math. Like, you ask yourself, all right, 2 to what power gives you 32? Well, 2 to the 5th equals 32. So it's almost like you want to look at both sides and get the bases to equal each other. And then you just set the exponents equal to each other. So I just proved that x equals 5, because 2 to the 5th is 32. Okay, if I did number 2, if I look at this, 16x equals, or 16 to the x equals 4. Now, this is actually bigger than the 4, but I could rewrite, this is like saying 4 to the 1st. I could rewrite 16 so the base is 4. This is like saying 4 squared, and then that's raised to the x, and it equals 4 to the 1st. And if I have 4 squared and it's raised to the x, we just multiply those exponents, so it's 4 to the 2x equals 4 to the 1st. And once I see that I have the bases are equal, then I set the exponents equal to each other. So if I have 2x equals 1, well then we see x equals 1/2. The shortcut to that one is you could see if you take the square root of 16, square root of 16 equals 4. And remember, if you take the square root of 16, that is the same exact thing as taking 16, raising it to the 1/2, and it equals 4. So either way, 2 different ways to do it. But the main thing is here is that you can rewrite both sides so that the bases are the same. You've seen that before. So that's review. Now what's different is 3, 4, 5, and 6. We're going to do 3 through 6 on the video, and then the last 4, 7 through 10 we're going to do in class. Okay, if we look at 3, the one thing with this 72, I could not rewrite this so it gives me like 4 cubed is 64, and 4 to the 4th gives me a much bigger number than 72. So I'm not going to get a whole number like I did for 1 and 2. And 2 was a nice fraction, 1/2. Now this, I don't know. I think, let's see here, 4 to the 3rd is 64. 4 to the 4th gives us a much bigger number. In fact, I'm not even sure what it is. I know that I'm going to put this, it's much bigger than 72. So I know if you solve for x, it's going to be between 3 and 4. But probably a little bit closer to 3, because this is going to be a much bigger number than 72. Well, how do we find it? Well, this is where we do the inverse. The inverse of exponential equations is logarithms. So this is where we use logarithms. Now, the whole key is our base. Our base is 4. So I'm going to take the logarithm of each side, but I'm going to keep the base of 4. So this is what I'm going to do. I'm going to do log base 4 of 4 to the x equals log base 4 of 72. Okay, let's erase this. Let's erase all of this. Okay, this is how you would do this problem right here. Now the reason why I do this on the left side, log base 4 of 4 to the x, this is one of the basic properties. These kind of cancel out and it just equals x. So x equals log base 4 of 72. Okay, great thing about the T-Inspire, just put this in your calculator and it's going to give you the answer. If you put that in your calculator, you get this to equal around 3.085. And there it is. It's much closer to 3 than it is to 4. Okay, let's move on to number 4. Now number 4, we wanted to make it look like number 3. So I'm going to write this here, and we're going to use this as kind of a goal for basically problems 4, 5, and 6. What you want to do for 4, 5, and 6 is you want to isolate the power, or the exponent. Well, you want to isolate the base in the exponent. So what this means is I want to get this 2 to the x by itself. So in order to do that, I have to get rid of the 3. Since it's 3 times 2 to the x, I divide both sides by 3. That cancels. I just have 2 to the x by itself. I divide the right side by 3. 42 divided by 3 is 14. Now, I kind of know, before I even do the calculator, let's see here. 2 to the 3rd is going to give me 8, and 2 to the 4th is 16. So my answer is going to be between 3 and 4. And it's going to be a long, ugly decimal. Here it is, the key. This is our base. Our base is 2. So I'm going to do this in a different color to emphasize this. So I'm going to take log base 2. I'm going to do this, log base 2 of this, and then I'll squeeze this in here, log base 2 of this 14. So this left side just equals x. And then the right side is log base 2 of 14. And then from here, just put it in your TI Inspire, and that's it. That's your answer. So when you put this in your TI Inspire, log base 2 of 14 winds up giving us 3.807. And that makes sense because remember we said 2 to the 4th was 16, which is very close to that 14. So that's why 3.807 is really close to the 4. Okay, number 5, this is one where we use e. So remember, the inverse of e is natural log. Now I want to get this e by itself. So first thing I do is subtract 5 from both sides. So we have e to the x equals 55. And then as soon as I have that base and power by itself, then I take the logarithm of each side. Well, if you take log base of e, that's the same as doing the natural log. So I'm going to put this in a different color. I'm going to do natural log of e to the x equals natural log of 55. Now this side, natural log of e to the x, this is one of the properties, this just equals this. It equals x. So x is going to wind up equaling natural log of 55. Then you're home free. Then you just plug and chug, put this on your calculator, and natural log of 55 would give you around 4.007. And then that's it. Okay, number 6. When I look at number 6, I'm going to use my arrow here. I ask myself, all right, where's the base? Where's the power? Well, it's right here. So my goal is I want to get this 3 to the 2x minus 5. I want to get this completely by itself. So I have to get rid of this 2, and I have to get rid of this negative 4. Well, I'm going to have to get rid of this negative 4 first by adding. So I add 4 to both sides. That cancels. Add 4 to the right. So I have 2 times 3 to the 2x minus 5. And on the right side, 11 plus 4 is 15. Then, to get rid of this 2, it's 2 times the base, 3 to the 2x minus 5, so I have to divide by 2. So I divide this by 2, divide this by 2, and I'm going to have 3 to the 2x minus 5. And 15 over 2, that is a decimal, is 7.5. All right. Now, I'm going to work underneath. I'm going to go all the way underneath here. You know, it's always more sloppy when I put it on the video. Okay. Now I have this base of 3 completely by itself. So if I use a different color, now I have to take the log of both sides. Since the base is 3, I take log base 3 of each side. And log base 3 of that 7.5. So this is what I should have. I'm going to rewrite this. I'm going to have log base 3 of 3 to the 2x minus 5 equals log base 3 of the 7.5. Now it's going to be a little bit more work because I don't just have an exponent of x. My exponent is 2x minus 5. Now when I evaluate that on the left side, this goes away and it just equals the exponent of 2x minus 5. On the right side, just put this in your TI Inspire. Let's see here, 3 to the first is 3, 3 squared is 9. So this is going to be equal between 1 and 2, probably closer to 2. So this is going to be closer to 2. I don't know what this exact decimal will be. Let's take out my calculator, let's evaluate it. All right, so when you put that in your calculator, you get this to be around, I'm going to round this, like 1.8, what's it look like, 34. And then to get x by itself, well then you just add 5 and divide by 2. So really, x is going to equal this. I'm just going to skip steps. X is going to equal this 1.834. Well, you're first going to add 5 to it. So you'll get 6.834, and then divide that by 2. So then when you take that 6.834 and divide it by 2, you get your answer to be this, about 3.417. All right, so what's new is taking the logarithm or natural log of both sides, But the main thing you want to do is, I would say this, I'll highlight this. This is what you want to do. That's the key to doing 4, 5, and 6. Isolate the power. Get that by itself. Once you do that, take the logarithm of both sides.